Okay, everybody, welcome back from the break, and we are going to continue with defining data visualization and the part 2. And to introduce these other concepts, then we are going to start discussing the types of visualization. And the two types of visualization that we have are the static and the interactive. And what are the difference between the static and the interactive visualization? Basically, when we have a static visualizations, are those ones that the user cannot change in any way, and they are used generally for support storytelling. They can be diagrams, charts. They can be embedded in a larger body of text. That's the way that we do PowerPoints, do presentations, we write papers, we do reports. That's the static visualization. Then the text that is surrounding or in companion of the visualization, they convey the story, and the image usually provides supporting evidence or related details. It's usually the way that we present that. And some new emerging class of visualization that we're going to be exploring, they try to combine narratives with some static or interactive graphics. Then there start to be a blurry line between what is static and what is interactive. And now the interactive visualization are those what basically the user can manipulate in some way and explore the data relationship and explore the mapping and explore the representation, and then it can help the humans to detect new patterns. I have a missing N here, I'm sorry. And detect those patterns and identify new ways of using the data or understand the data. The new technologies have the potential to transform raw data into really actionable insights, and we can use different techniques in order to given that this threshold, then this is what you should be doing or triggering this action to the people. And let's think. So for example, we're following the how well some population of patients are doing, and if we see that some of them are just getting out of the parameters, maybe that's going to trigger you need to focus on them and create some actions. And this enables a more efficient population management and support better understanding of some health outcomes. Because sometimes when we see the data about patient, or we cannot see those differences, we cannot contrast. But when we have visualization, we have this data, we can understand, or I did an intervention and the tendency or the trend changes. That it was positive, it was negative, or didn't change, then it didn't work. Then do I need to try something different? Then those are the type of interactions that we have, the static and the interactive. And the interactive has all these possibilities to be incorporated in this process that we can call clinical decision support, or public health decision support system, or strategic decision support system. Then understanding the best way of visualize data and visualize this type of information that we want to convey is a central challenge in order to improve healthcare. Why? Because we're generating so much data that if we don't aggregate that in visual representations, the human brains are not able to consume the data in the way that we are producing that, and we need to transform that in some way. Then here is another example of the different stages or that pipeline that we can follow in order to obtain the results that we want. But when we are talking about a project in visualization, not only the pipeline, then we need to start with, we are going to be what is the conceptualization of the project, why we are doing this, what is the problem that we want to solve, what is the data set that we are going to be using, what are the vision and the goals, and then here is where we have that import and process, and then we need to understand that data in order to be able to do the transforms or the manipulation. And this is the pipeline, no? The pipeline that we saw, where we do the data mapping, we do the presentation design, and we do the interaction design, and we test them. No, we need to test those designs with the different users, and then we create a documentation. And once we test the designs, we test the prototypes, we test the things that we are thinking, then we go and move into production or development. It's not really cost efficient to start doing any coding or any programming in visualization tools, especially in computers, or if we are not having a good understanding of how it's going to look, what is going to interact, and a validation of that, because developing is costly in time and resources, but design on paper and in discount methodologies is really easy, and we are going to explore that. And then once we develop or we program the things, then we implement and we deploy. But then the pipeline is embedded here, but we need to have, as you see, an approach from the project management perspective and in some way human-centered design, because at the end we are generating visual representations, we are generating software in some way that people is going to be interacted. Then this is an information system, and we need those resources that we have from the information system design in order to be we need them and apply them in the different process. And that's why we are insisting in the beginning, hey, you need to know your audience, and then you need to work with them, and then you need to test this, and it's interactive, and it's a trial and error. There are rule of thumbs, but not always things work in the way that we think. Then more terms that are going to help us to understand data visualization. Then we're going to be talking about format, and we're going to start with the static visualization. And then the first thing is the charts, or the type of charts. And what is a chart? A chart is an individual visual representation of the data, and we are familiar with this bar chart. And a data can be represented in so many ways. That's the mapping process that we have been talking about. And a chart uses different marks, shapes, or layouts, and those different marks are the ones that are going to define the name of the chart that we are using. And then this is the bar chart. We can have pie charts, we can have line charts, and we are going to have different charts. We also remember the need to consider the data set, that basically we already introduced that, the collection of data that we are going to be using for the visualization. The data sets, they can be in form of tables, that basically we have rows and columns. Usually we have the observations as rows, and usually we have the variables as columns. But sometimes we need to transpond, or we need to transform those representations depending on what type of aggregation we want to do, or what's the type of question that we are answering. Usually when we have a table representation, rows, we call them records, okay? And the columns, we call them variables. And we can visualize data sets as tables, and that allows us, for example, in this case that we are just counting, to see or to measure the magnitude or the relationship of those patterns. But sometimes we need to correct the things, because the question that we are asking is not answered directly just by the numbers, and we need to contrast that. Now, data source is another element that is really important in a visualization, and has to be presented. Is where is that data coming from? or just magically appear. How we achieve that, because that's going to be really important in creating confidence. Sometimes it's going to appear near the bottom of the page, or if the visualization is within an article, then it's going to be in the text. But it's really important to always provide the source that we are using in order to create some trust in the audience. We have the axis. Usually our graphs are two-dimensional. They have two axes, the x and y. We may have three-dimensional representations, but since we interact with a 2D space, it's a little bit tricky sometimes, but you are going to discover when we add areas, we add colors, we are actually adding dimensions and conveying information in that way. We can make things complex, but it's really important to understand, if we are representing x and y, there is no other reason why you need to put this in a 3D. It's really common to see this type of charts that only have two dimensions represented as a three-dimensional data, when the data doesn't have that property. Then we need to be aware of that, how many dimensions we have, and then how many axes are we going to be providing there. And usually we have just x and y, but we are going to see that we can have more than two axes and make the thing multidimensional. And in those axes is usually where we see the scale that we are going to introduce, and are the reference point to basically what we are seeing. Now, what is the scale? The scale is that contrast that allows to understand what are we measuring and how we are measuring that. It could be intervals, but any scale can be linear, could be logarithmic, could be exponential, or we can have arbitrary scales when we are using color shades, things like that. That's going to represent also a magnitude. Like in the next example, for example, you see that the total cases, they are represented in magnitude, and we have a scale here. But also at the same time, this is the legend. The legend is telling us the meaning of the marks, and in this case we have a map. This is called a choropleth, that we are representing magnitudes within countries using the intensity of color, and it's a key element to tell us how things are related. So you see this sometimes. We can play with the scale here and the magnitudes and create some interesting contrast, and we are going to look at that. And also, that's something that could be abused, but we need to be careful that not doing that. And that legend is going to help in that reading, in explaining that chart to the user. Now the variables, we already said that those are the different items from the data that basically describe a thing. It could be name, date of birth, gender, you name it. No, any of those observable characteristics, observable properties, or measurable properties of a subject. When I'm taking up subject, is not an individual. It could be an artifact, it could be an element, it could be a country, it could be a phenomenon, you name it. And they can be quantitative, they can be categorical, they can be text-based. And remember the graph that I said, that graph is going to be really useful to try to do that mapping, because then, hey, what type of data I have, how is the variable collected, how is the variable represented, can I transform the variable from one to other, and how I'm going to do that map. Usually we have chart plots that are a relationship between two variables. Another important concept that those that are familiar with statistics, most of you already took the statistics course, are the outliers, and those are basically the data points that are outside of the expected range and they behave in weird ways. And sometimes visualization is going to help us to identify those outliers, or if there are clusters or different organization of data that is not easy to see, for example, in a data set or a table. Sometimes individuals fit in the pattern, and those that don't fit there are the ones that we call outliers, because we can have a pattern and say, oh, this is described by the formula, or I have this area that it's describing the group, and that's the cluster, and somebody outside is going to be the outlier. Also, when we have an interactive visualization, we are going to have something that we call the input area. And the input area is where we can enter some information into that visualization. It could be a search, could be an element to filter, could be an element that we want to drill down. There are different elements that we can have as an input, and when we start having inputs is when we are moving from that static visualization into the dynamic or the interactive visualization. Then, when you are looking into a visualization, you are going to be also looking for these things, and always you are going to be having a critical eye from now on. I want you to, every single time that you are looking into a visualization, and we are going to have a homework where we are going to apply these principles, then you need to check for 5 things to try to make sense of the visualization. First, what is the title? Okay, the title is giving me the introduction. Now, how many axes, and what are the scales, and what are the type of measurement that I'm having there? Is there a key, a legend that I can use to translate that? Can I identify a data source? It's reliable. And now I look into the data. It's important to understand that not all visualizations have all the 5 features. It doesn't mean that it's a bad visualization, but it's desirable to have these elements at least to help the user navigate. And those are the basic instructions that our brains are expecting to have in a visualization in order to be able to consume it. Some visualization may not need them. Sometimes a word map doesn't need a scale unless we are doing a chloropet, that we are going to be talking about that, and we provide an example earlier. Sometimes the feature that we want to represent is present but is not obvious. Then sometimes we need to click at, for example, sources, or the key or the legend in interactive visualization, or when we have dashboards that are really busy. Sometimes those features are going to be hidden, then we need to do an action in order to retrieve them, like the labels or the data source. Sometimes the scales, because you can have a rough idea, you don't have the absolute values, and then you invoke the values. But the other thing is, if we don't have all those things, then we are going to have challenges understanding the visualization, because those are the things that our brain expects to have. Then there are some examples here of charts and application. Then we can have a bar chart where we have 2 measurements that are described down here, that are new cases and the total fatality, and then we can visually compare ratios and scales and do a categorical comparison. We can have a line chart. This is the same data represented in different ways, and we can have that same data represented like a line, you see, but then now the comparison is in a vertical way, but it's easier to read the trends, because in the bar chart you need to see the trend here and then try to follow the trend down here. It's a little bit more busy for our brain to separate the 2 pieces of information, and This pie chart is showing the relationship of all cases, how many are new and how many are dead. It's basically the same data represented in a different way, but then in this case we are losing the temporal evolution, for example, and the dynamic of the element. And then now we go back. What is the question that we are asking, and what is the question that we want to answer? No. Here are examples. Then, is there a key in this map? Yes, there is a key. What is telling this? The colors and the shapes, because okay, I have the colors, but if you are not familiar with this country, that is India, but you don't know the states, okay, then now we are lost. I don't know the states of India, and I haven't studied Indian geography. Then you see that like an external user, maybe this is not conveying information. Yes, the data is there, but I cannot interpret this. I am not able to extract any information from here because I don't understand or I don't have a clear key what these shapes represents. I can locate them in a map, but are there important cities there or there are a particular interest? I don't know. Title, then you are going to be looking for the title, and is there a title? And it's giving us the information about what we expect in the chart. Then this is countries with highest COVID-19 case and fatality per million on July 17, 2020. Okay. Then we have the countries, and we have 5 here. Then it was United States, Peru, Brazil, Russia, and India. And we have the cases per million, or cases, yes, cases per million, and we have that corrected in order to compare that prevalence that we have it there. Then let's talk about charts now, because we talk about the elements that we want to have there. That are what? That are the title, the access and scale, the key, the data source, and the data itself. And when we are talking about charts, we need to think about what is the format and what is the task size, and then how big is the task on reading the visualization. Is this difficult? Is this complex? Do I need to synthesize this in some way? If we are dealing with a static visualization, we need to ask ourselves how large and how varied is the context. Is this dense with lot of charts like this particular thing, or is quiet and small and compact? If there is an interactive visualization, how much interactivity is there? Are too many buttons, menus, options, etc. that is going to make this really complex? If the visualization doesn't fit on your screen, how much scrolling has the people to go to different pages? And then other thing that we're going to be emphasizing, human beings, we do scroll in one direction, we don't do scroll in 2 directions. Is too overwhelming that we resign to the task once we make the task so difficult. Then if we want to read a chart, then in theory the designers created that visualization selecting the most appropriate chart type. But remember, to whom? To a particular audience. And the example of India, maybe that chart was created to Indian audience and is not helping people like me that I don't know Indian geography understand clearly what is in there. And then we are going to have those visual marks and the attributes and the different things that is going to be there, and are they easy to read? The marks and the attributes and the properties. Okay. Then what are the visualization functions that we were talking initially? Then we can have to visualize how a variable or a set of variables are distributed, we can identify the correlations, how two or more variables are related to each other. We can have rankings. Who is better or who is doing worse, or how things are evolving. We want to look parts of a whole and how things just split and how they are composed, and we have different techniques for that. We want to see how time changes the dynamic of an observation, of a series of observation, and how things evolve on time. We want to see things with a coordinate reference or a map. And we can see also how things flow, or how elements move from one category to another category, and we have those elements. And this is another example of charts that we can have, and you can find them in this rgraphgallery.com/index.html. This is a really interesting tool that we are not going to be using directly in the class, but I want you to know. And it's a whole series of tutorials. They have 400 visualization tools there for R. Then how to create these visualizations in R, if you want to go, this is a really interesting place. I'm not going to ask you to use R because the complexity in cleaning and manipulating data sometimes is going to be overwhelm some of the students. We are going to be using other tools that don't require so much coding, programming. I don't want you to invest a lot of time in that portion. I want you to concentrate more in the visual aspects, and once you understand the visual aspects, you can translate that into elements like R, or the other ones that we are going to be presenting, like the Google Graphs or JavaScript or things like that, that we can have really interesting graphs. But in the distribution, then we have the violin graphs, charts, the density charts, that is quite common, that we have seen, like the Gauss distribution, the Gaussian distribution, or the Gaussian belt, the histogram, that is similar, but we have density measurements, and we have histograms that we have discrete values. In density we have continuous values. We can have the box plot, we can have rich lines, and when we are doing correlation, the famous scatter plot, where we can have something that is called heat maps. We can have correlograms, we have bubble graphs, connected scatters, and we can have a two-dimensional density graphs that are basically taking this 1, 2, and then the density is actually a third dimension. This is a three-dimensional graph. The correlograph, this is a three-dimensional graph. The heat maps are three-dimensional maps. The bubbles are three-dimensional graphs, because you have the two axes and the size of the element, the intensity or the density of the element. Actually, this could be even 4 dimensions, because the size is going to be 1 dimension and the color is going to be a fourth one. When we do ranking, we can have the bar plots. We saw that with the countries, the more frequent COVID for that particular date. We can have the radar or spider web. We can have the word clouds, parallel lines, the lollipops, the circular bar plots. If we want to do part of a whole, the tree maps are the most common, but we can also have the group and stack bar plots that sometimes they are not used properly, or we can have also a stack areas plots to represent that. We have the donuts, the pie charts are the tradition part of a wholes. We can have dendrograms. We can have circular packing that is similar to the tree map, but instead of using squares, is using the concept of these areas and circles. Evolution, the traditional line plot. the area, the stack area, that could be also part of a whole because we can normalize this. The stream chart, that it's similar to the stack areas, only that is smoothed in some way. We can have time series that are elements by itself, and then we can see different things running on time. When we have maps, then we have the traditional map, the traditional geographical representation. We have the choropleth that I briefly introduced you. There are some other representation, that is the hex bin map, that is you divide the area in hexagons, and then you represent a variable and density of the variable within that. This is representing France, and France is here. We can have cartograms. This is England. We can have connections. How a case index, or how the relationships between individuals and to track pandemic. We can have the bubble maps to represent dimensions and magnitudes in relationship with the geographical information, and then we have the dimension, the size of the bubble, and we can have on top of that color. Then we already have 1, 2 dimensions, third and fourth dimensions. Then we can convey a lot of data with those dates. And the flow, then the core diagram really used a lot for social network analysis, the traditional network graph, the Sankey graph, or the alluvial graph, arc diagrams, and the edge bundling. That this is also to try to understand relationships, but between individuals, and this able to create groups or segments of groups. Then let's see some principles or some examples quickly. Then an application, the bar chart. Then what uses that? The length of the bar is the one that represents the quantity, and we can have different categories, and then we can have multiple ones. This is what I was telling you, that this is a two-dimensional graph, and there is no need to create a third dimension, because that third dimension makes it look pretty, but sometimes we don't need to create that additional information, because you see that effect that this creates. And if we make them big enough, then is that going to be represented as a peak, or is that darker color represent something else? Not everybody has the capability of see that these are like prisons there, and it can create some confusion. But the stack bars uses the length for 2 or more stack variables, and then it represents the total and the proportion that we have in that proportion for some of the variables of interest. The radar, then every single axis of the radar is going to represent a different measurement or a different quantity, and we can start seeing some interesting graphic patterns of behavior when we put the properties here. Then these 3 countries, United States, Brazil, and India, with total cases, new cases, and fatality, we don't see that much difference between them. But remember that in total of cases, we were seeing a little bit of a difference, but this is susceptible of resolution. And if you see here, we are using a logarithmic scale in order to be able to amplify the effect, because if not, it will be too big, the scale. But it's really useful, because you can discover some patterns in some phenomena that are modifying the variables. The pie chart, then the circular one, and usually then we have part and whole, and they represent percentages. We need to be careful that actually total cases here, new cases, and fatality is representing an error. Why? Because total cases include the total fatality and the new cases. Then we need to be careful when we represent this. Then these are going to be the all cases. We need to subtract from total the new and the total fatality. We need to be sure that there are no new cases that also are fatality, and we need to do some operations there. Then you need to be careful, because yes, you can make a pie chart, but not really conveying the information that we want to convey, because even though this says that 95.2, in reality this represents the 100%, and this fraction is not then the same because it's not corrected properly. Three maps, again for composition of a whole, and we have many components or many subcategories, and usually they are rectangular areas that they are subsequently divided in every subcategory, and they can be really interactive, really interesting, and we can drill down within them. And these are really good when we have more than 3 or 4 segments, and because it's really difficult to present this in a pie chart. You start having these angular representations that are really tiny, and you are not going to see the small groups like the ones that we have down here really well in a pie chart. The scatter plot, two numerical variables, two quantitative values that we have, and then we plot the observations against those two variables, and every single point is going to be an observation. And sometimes we can just join the dots, or we can have some formulas that can describe the behavior of that dot and be able to describe the data. The heat map is a matrix layout, where in this case we have countries, we have years, and then we have values that we assign to every single cell. And the cell is coded by a color, and then it's going to show us intensity, or it could be a hue or a density, not necessarily a different color, but a density of magnitude. And then, for example, the darker cells indicate some popularity or things like that. This is showing variations in lung cancer across different countries, across different years from the 50s to 2012. And then you can see, hey, it was low the incidence, then the incidence went up and then went down. Interestingly, it has been controlled and it started appearing. And you can describe some interesting phenomena using these heat maps. The line chart, I think everybody has seen that. Usually we have a temporal variable in the x-axis, and we have an observation in the y. Yes, then usually we use time, and is how we are used to see trends. Slope graphs is used to show a before and after, then what is the value before and after and how it changes, or if the thing is preserved, and then we only have 2 points of observation, and the values are connected by slopes, and usually the analysis is made by the angle of the slope, how that slope is, and is where we are going to look at that. The stack area, again, 3D representation that is not the most appropriate way of representing areas, because areas are two-dimensional. when you add that dimension, yes, it could be interesting, but if you see there is already a deformity created by the perspective into the data, and this can create false representations or false interpretations on some data. Then we need to be careful when we are representing two-dimensional data and try to avoid to use a three-dimensional rendering. Then this is an stack area, and this is not really an stack area. This is multiple lines, because if you see, we are not adding to a 100%. We are just representing different values, but we are not stacking them, and then this is not an actual stack area chart, even though it kind of looks like, but we can convert that easily into a stack bar and a stack chart, and it's going to present us. Then each color represents one part of the whole that is stacked vertically, and the height of each color represents that proportion of the part. Then, as we said here, maybe stacking this is going to be different. The choropleth map is the one that uses that color coding to indicate values across different geographical areas, and I think you are familiar with this type of representation since COVID, and typically the darker the color is, the higher the value. We also have a symbol map. This is another representation of density and location, and this has not only the country, but it has some cities, and this is a proportional symbol map that every single mark that is a circle in this case is positioned geographically and represents a magnitude, and the marker is the size and not the color as here. Sometimes we have two dimensions represented in addition, then we have the size and we have the color, and we have a multi-dimensional map there. We also have the flow diagrams or the alluvion diagrams. This is a Sankey diagram for the evolution of COVID and how the clinical trials were registered in different medications. Then we can see the countries and where the medications of the therapies that they were trying for those different interventions, and which country were working on that. And we can see that like hydroxychloroquine was being tested basically in every single country, and United States was testing basically every single drug. They were countries that they didn't test all of them, and then we can have a lot of conclusions from this type of diagram. What challenges we have them in data visualization? Then creating those custom visualizations is challenging, and it's a problem with multiple dimensions. We need a combination of skills and tools that involve data analysis, design, and development, and those are the skills that we are going to be developing in this class. And designers and developers, they need to gain understanding of the data sets and the characteristics in order to be able to map them properly. And that's why usually being an expert in the matter and understanding the design process and developing process is really important. Maybe in the future you are going to have designers and you are going to have developers, but you need to understand how to define this, because you are going to be the owner of the data. And if you know how to design, then you can speed up the process. And if you know how to develop, you can help to speed up the process and gain efficiency in the process. Or you can be designers and you can be developers. For the class, we are going to be assuming the role of designers. And in some exercises, we are going to be doing some development. Then we are going to assume those roles, but remember that we can always have people helping us. Then That's going to give us the introduction of dashboards. Where are the dashboards in all these things, no? Then basically a dashboard is a visual and interactive performance tool. It's a visualization, but it's interactive by principles. It's going to display in a single screen the most important information to achieve one or several objectives or tasks. And those dashboards are going to allow the users to identify, explore, and communicate a problem that needs correction actions. There are dashboards as simple as the car dashboards. You have your engine revolution, you have your speed, and you have your temperature, and you have your information there, and then you have your distance. You have also some that are occupancy in the hospitals, a single indicator. Are we overoccupied? Are we with some capacity to respond? Or we need more patients? Hopefully we should have people at home and not bringing them to the hospitals and be healthy always. But yes, we can have a single indicator in a dashboard. Then the dashboards are going to incorporate those visual and functional features that allow users to understand the current management practices, identify critical variations, and they can benchmark the data against some indicators. You can have some thresholds and see how your data is going through that threshold and be able to make decisions based on that. And the dashboards provide a visual summary of that decision related with the information that is displayed in graphs, charts, and different interactive tables. What are the features of a dashboard? Then functional features are related indirectly to visualizations, but directly are going to describe what the dashboard can do. Then a dashboard is going to have a function. Hey, what can we do? What kind of data I can? What kind of questions can I ask here? And it's going to have some visual features that are basically referring to the principles of visualization data about efficiency, efficacy, and those mappings that we were talking today. There are different types of dashboards. We can have strategic dashboards, analytical dashboards, and operational dashboards. There are 3 different levels. The operational ones are the ones that are at in a daily base, and they are in dynamic context. They have almost real-time updates, and usually applies simple display media because we need to be making decisions constantly. The analytical dashboards are usually static snapshots in certain periods of times, like weekly or monthly or yearly, depending, and they allow us to drill down into features and investigate data further. They allow us to understand a problem, how it's behaving over time, and not necessary to respond right now. And the strategic one are really high level overviews of the most important metrics of a process or a business performance, and sometimes it's going to provide some predictive measures, and you can do some simulations in the future. Then it can do projections. Hey, if we continue in this way, this is how we are going to be in 1 week, in 1 month, or in 1 day, and then you need to change or not your behavior in order to change the direction of the operation. Usually they have low interactivity and they have low context because they are really big in scope. Then, for example, an operational dashboard is how is the occupancy of the ICUs today. An analytical dashboard is the one that is going to provide us what are the diagnoses that were in those ICUs. And the strategic one could be what is the infection rate that I have of multi-resistant bugs in different organizations in my geographical area of influence, and then what kind of actions do I need to conduct in order to improve the health care delivery. And then when we talk about those interactive visualization, then we have to have those drill down capabilities is a key functional features to balance the information load, and be able to have mechanisms as filtering, zooming, are going to reduce the chance of being overwhelmed, because if you try to present everything, our brain is going to be overwhelmed. I already explained you why, and is going to help when we have those interactive visualizations and capabilities of filtering and zooming to help people interpret better public health indicators. And these interactive features in the interactive visualization in a dashboard are features that can improve the interpretation process and use and increasing the user's performance in that regards. Then, what are the common mistakes when we are designing dashboards? And sometimes we provide inadequate context. We don't use proper design methods. We encode the quantity of data in an inaccurate way. We show excessive details. We don't highlight the data that we want to highlight. There is a meaningless variety. We are against that consistency that we were talking about. The data is not arranged properly. And what are the guidelines? Then organize the information to support the meaning and the use. We need to maintain consistency. We need to design for use, and we test the design for usability. You see, this is a trial and error. Then the dashboards are no more than interactive visualizations that are using multidimensional representations, and then we can drill down into the data. Then the best practices that we want to achieve at the end of this course, as we are going to learn how to tell a clear story, how to arrange the most important visualization, and starting to the top left in our cultural context, because we read left to right, top to bottom. It can change by cultures. Contextualize the information with bold text or symbols. Allow the user to retrieve the most important information in just 5 seconds, right away. And then if has queries and wants to see more, then go deeper. No user should be able to switch between 10 dashboard instances. Then yes, they are not make that thing complex. Color need to provide visual cues, but we need to be careful in the way that we are conveying meaning. We need to be careful that too much styling, too much embellishments could be out of balance and create information load, and then instead of helping, it could be damaging. And if possible, a dashboard should support the drill down features and be able to move or hide things that are extraneous, like the header, bar, and logo, and just focus in the data and visualization, because sometimes those things that are labeling are distracting. And some examples that we are going to be exploring are performance dashboard, how we are doing achieving some goals, quality dashboards, are we having a lot of readmissions in the system, safety dashboards, what are the incidents of sentinel events, clinician dashboards, how are my patients doing, is any patient in particular out of the expected values, patient perception dashboards, those are about evaluation of service, health organization dashboards, those are the ones that are going to tell how we are behaving. Then today we have gone through the basic concepts of visualization, the basic elements of what they need to be in a visualization, some functions that we can that we can support with visualization, some examples of mapping the data into visualizations, and we introduce the concept of the dashboards and how dashboards is a specialized interactive visualization form. I expect that this has been informative, and I'm looking to receive some questions. I'll be more happy to entertain them, and see you in the interactive session if you can come and join us. Thank you very much, and have a good one.